One topic we didn't spend much time on early in the year when it came up is absolute value. So now that we have a little extra time, I want to look more closely at absolute value. And so we're going to look at two types of problems here. One where you're solving an equation that involves absolute value, and then the other where you have to graph a function that includes an absolute value. So I'm going to start with this equation on the left here. And the thing you have to keep in mind when doing an equation with absolute value is your first goal, your first objective is to get the absolute value by itself. So we would start this like any equation by adding the 4. And we'd have 5 times the absolute value of 2x plus 6 equals 70. And then right here, because we want to get the absolute value by itself, we don't want to distribute the 5. And because it's an absolute value, we can't really distribute the 5. That's going to cause some problems. So what we need to do here is divide this 5, get rid of it by division. And what that does is it gets this absolute value of 2x plus 6 by itself, and it's going to be equal to 14. Once the absolute value is by itself, once you've isolated it, then you split the equation. The idea here is 2x plus 6, it could be equal to 14. But because it's an absolute value, it could also be equal to negative 14. Either one of those values would give you the same absolute value. So you're going to set up two equations, and you have to solve them both. So the first equation, we'll subtract 6, and then we'll divide by the 2, and we will get x equals 4. So if x is equal to 4, when you plug it in there, the absolute value ends up equaling 14. And when you multiply it and subtract the 4, you get 66. So that's one correct answer, x equals 4. Let's solve this other equation. Again, subtract the 6. This time we're going to have 2x equals negative 20. We'll divide by the 2. X is equal to negative 10. So negative 10, same thing. If you plug it into the absolute value, it's going to end up giving you a 14. When you multiply that by 5 and subtract the 4, you'll get 66. So there's two values that would give you a correct answer to this equation, 4 and negative 10. So we had a second equation. It's not really too different here. Let's go ahead and start this one off by taking care of that 5 on the bottom of the fraction. So we'll multiply both sides by 5. And the nice thing about this one is right away we get the absolute value by itself. And we have absolute value of 3x minus 7 equals 40. So now we can split the equation. Do 3x minus 7 equals positive 40. 3x minus 7 equals negative 40. And then we can just work this out from here. We will get 3x equals positive 47 for one of them. And when we divide by 3, I'm just going to leave this as a fraction. X is equal to 47 thirds. And you can make it into a decimal if you want, but it's probably best just to leave it as a fraction. That's going to be the most precise answer. So 47 thirds is one solution. Now we're going to work out this other one. So we're going to add 7 to both sides again. This time we're going to get 3x equals, if we have negative 40 and positive 7, that's going to be negative 33. And when we divide that, this one's going to work out pretty nicely. We're going to get negative 11. So those are the two values that would satisfy this equation, 47 thirds and negative 11. So that's solving equations with absolute value. It's really not much different than solving other equations. You just reach this step where you have to split it into two separate equations to get two separate values. Graphing absolute value, I think we did do a little bit of this, but I just want to run through how you would want to set up your table of values to graph this equation. So oftentimes when we're graphing equations, we make a table of values, we plug something in for x and get a value for y. When we're doing absolute value, here's, I think, the best way to start. Take whatever's in the absolute value, 2x minus 6 for this first one. Set it equal to 0. The reason I'm setting it equal to 0 is because 0 is the one number that is neither positive nor negative. So if you get 0 in your absolute value, you're only going to have 1 point with that y value. And that point is going to end up being the vertex of your function. And you'll see this a little bit when I graph it, but absolute value functions are V-shaped. And they come to a point, they come to a vertex. And that vertex is going to be wherever the function is equal to 0. So we're going to take 2x minus 6 equals 0. And I'm going to add 6 to both sides. And I get 2x equals 6, so x equals 3. So the very first thing I want to do is plug in a 3 for x. And if I plug in a 3 for x and I work this out, I know I'm going to get 0 in the absolute value. Then I add the 2, so 0 plus 2 is 2. Okay, now what I want to do is plug in things on either side of the 3. So I'll plug in a 2. So here I'm going to have 2 times 2 minus 6 plus 2. It's going to give me 4 minus 6 plus 2. 4 minus 6 is negative 2. And when I take the absolute value of negative 2, it's going to be positive 2. And I get 2 plus 2 equals 4. So if I plug in 2, I get 4. I'm going to go on the other side of 3 and plug in a 4. Well, if I plug in a 4, what I'm going to get this time is I'm going to get 2 times 4 minus 6. And when you do 2 times 4 minus 6, that's going to give you 8 minus 6, or positive 2, and then plus 2. And so what's going to happen is when I plug in a 4, I'm still going to get a 4. And I don't have a lot of space here to keep plugging things in, but you're going to see a pattern here. So let's go ahead and plot what we have. We have a point at 3, 2. Like I said, that should be the vertex point where the absolute value comes to a point. Because again, this is going to be V-shaped. I'm going to have a 2, 4. Oops, that's the wrong place. And I'm going to have a 4, 4. So let me get that in the right spot. And you can kind of see where this is going now. So let me go ahead and get 2 more points. Let me plug in 1. So I'm going to go 1 more to the left of the 3. And so if I plug a 1 in here, I'm going to squeeze this up at the top. It's going to be 2 times 1 minus 6 in the absolute value, then plus 2. So when I work this out, it's going to be 2 minus 6, which is negative 4, plus 2. My absolute value of negative 4 would be positive 4. When I add 2, that's going to give me positive 6. So 1 is going to get me a point at 6. So I got 1, 6. That's going to be right here. I'm also going to plug in 5. And you can probably see where this is going now. But let's just check it to make sure. So we have 2 times 5 minus 6 in the absolute value, and then plus 2. 2 times 5 is 10. 10 minus 6 is 4. We have the absolute value of 4 plus 2. That's going to be 4 plus 2, which again gives us 6. So what you should get, if you start by finding that vertex point where the absolute value is equal to 0, then when you go on either side of that, you should get numbers that match. So here we got 4 and 4. We got 6 and 6. And you should get this V shape. So this is the graph of absolute value of 2x minus 6 plus 2. All right. So the second example, what I want to do before I do this is change it slightly from what I originally put on the slide. So what I want to add here is this 1/2. I want to make it negative. So this is going to be negative 1/2, absolute value of x minus 2, and then minus 3. So again, what I want to start by doing is figuring out where is that absolute value, which is going to be the x minus 2. Where is the x minus 2 equal to 0? So just off to the side, I'm going to take x minus 2 equals 0. And when I work that out, I get x equals 2. So that's the first number I want to plug in here is 2. So I'll start with 2. All right, so what I want to do is plug in 2. So I'm going to have negative 1/2 absolute value of 2 minus 2, because I plugged 2 in for x, minus 3. And then I should get 0 in that absolute value, which I do. 0 times negative 1/2 is still 0. So I get 0 minus 3, which is equal to negative 3. So 2 puts me at negative 3. Now I want to go on either side of that. Now here's the one thing I do notice. I am multiplying by 1/2. So I could plug in anything, but this is going to be easiest if I get whole numbers that I can graph. And I'm going to get a whole number if I can keep the absolute value even. Since I'm taking half of it, I want even numbers here. So the next number I'm going to plug in when I go on either side, instead of doing 1 and 3, I'm going to do 0 and 4. Go a little bit further out here. So I'm going to plug a 0 in for x this time. So I got negative 1/2 times 0 minus 2, and then minus 3. Well, 0 minus 2 is negative 2. But since we take the absolute value, that's going to become positive 2. So I have negative 1/2 times positive 2, and then minus 3. Negative 1/2 of positive 2 would be negative 1. We'll have negative 1 minus 3, and that's going to give us negative 4. So 0 puts us at negative 4. Going on the other side, we're going to try positive 4 as our next number. And I know I'm running out of space here to write all these down, but we'll try to squeeze it in here. So we'll have negative 1/2 times 4 minus 2, and then minus 3. And when we work this out again, we're going to get 2 from the absolute value. So 4 minus 2 is 2. Absolute value of that is 2. So we're going to have negative 1/2 times 2 again, minus 3. And we've already worked that out, and we got negative 4. And that's what should happen. We should get identical numbers if we go on either side of that middle point. So let's go ahead and get 2 more. Let's plug in negative 2. So if I plug in negative 2 for x, again, I'm going to have negative 1/2. Then I'll have negative 2 minus 2. And then minus the 3. Well, negative 2 minus 2 is negative 4. Still in the absolute value. When I take the absolute value, that becomes positive 4. And negative 1/2 times 4 is going to be negative 2. And then minus 3 is going to be negative 5. So that's going to give me a negative 5. And I can plug in the other number would not be 5, it would be 6, because I'm counting by 2s. So I would plug in a 6. And because I'm out of space, if you want to verify this, you can by plugging in 6. But that will also give me negative 5. That will give me the same value. So now I'm going to go ahead and plot these. So our first point is going to be at 2, negative 3, which is down here. And then I've got a point at 0, negative 4. And I have a point at 4, negative 4. So those are going to be the next two. And then I've got negative 2, negative 5, so down here. And then positive 6, negative 5, which is over here. So then that goes this way. That goes that way. So that's what it's going to look like. So absolute value graphs are V's, and a couple of things you can look at here. The number that gets multiplied by the x, whether it's on the inside of the absolute value or on the outside, is going to determine your slope and how steep these two sides of the V are. A coefficient outside of the absolute, the sign of the coefficient outside of the absolute value is going to determine whether the V goes upward or downward. So on the first one, we don't really have anything outside of the absolute value as far as a coefficient, but it would be positive. And so that's going upward. On the second one, we have that negative 1/2. So that's going to make it go downward. So that's what absolute value graphs are like. So there you go.